the limit as n goes to infinity of sine of pi over n plus 1 plus sine 2 pi over n plus half, all the way up to sine n pi over n, that's sine pi over n plus 1 over n. So the fact that even if we want to use Riemann sum, right, we multiply everything by 1 over n, right, outside, then we multiply by n. Then this Riemann sum, right, Riemann. The width of every small interval is 1 over n, as long as we partition this interval 0 to 1 into n equal parts. Right? A functional value taken at the right edge of each small interval. But we cannot apply Riemann sum straight away, because those numbers are causing trouble. 1 half, 1/3, 1 over n. We only have n, right? So that motivates us to use squeeze theorem. So first of all, k goes from 1 to n. Sine k pi over n, or n plus 1 over k. Right? Less than or equal to, bigger than or equal to. First of all, the top is always positive, right? Sine 0, right? From sine 0 to sine pi, always positive. So as long as we make the bottom a little bit bigger, right, then the whole thing will become smaller. So maybe I can just replace every 1 over k with 1. Right? So that way. N plus 1 all the way. So sine k pi over pi. So likewise, if we can make the bottom a little bit smaller, then the whole thing will become bigger, right? Just get rid of 1 over k, right? For every term. So sigma over n sine k pi over pi. K goes from 1 to n. Right? On each side, we can apply the Riemann sum successfully this time. So for example, the right-hand side, right? The left-hand side will be similar, right? So we can just, right-hand side, multiply by 1 over n, then also multiply by n as well. So in other words, maybe just factor out 1 over n, right, outside here, then sigma sine k pi over n. K goes from 1 to n. So the Riemann sum, as n goes to infinity, this becomes integral from 0 to 1. Right? What's the function here? Sine, replace k over n with x. Like I said, function is taken that value at right edge of each small interval. So replace k over n with x. So pi times x dx. Right? And let pi x equal to t. So x is equal to t over pi. So dx is equal to dt over pi. I also change the boundaries to 0 to pi. Right? And also sine t dt, 1 over pi dt. Right? 1 over pi. So that way, of course, sine t, 0 to pi, integrate, I believe it's 2, right? So it's 2 over pi. So that's the limit of the right-hand side. Pi, 2 over pi. I believe the left-hand side will have the same result, right? Because the left-hand side is very similar. As long as we can multiply it by I want to make it look the same as this part. So all I need to do is to multiply it by 1 over n, of course, also multiply by n as well. Right? Also factor out 1 over n plus 1. Right? So I'm only left with sine k pi over n. Right? K goes from 1 to n. So this time this part is exactly the same as this part, right? Tending towards the same limit. 2 over pi. And of course, this part, n over n plus 1, obviously tending towards just 1, right? So the final answer is just 2 over pi.